So now with that being said, I'm going to jump over to just looking at an example and kind of walking through some of the main points that we talked about, how to put this input in to SACS to make sure that you're getting the responses that you want. And we'll take a look at some of the output and some of the pitfalls that I've seen people get into when they're looking at this. So we do have a dynamic analysis, DynPack analysis here. I'm not going to really talk about this too much. I will show you the model. It was the one at the first slide. So pull that up. I may already have it up. Okay. So we have just the top sides here, and we have a flare boom here. A lot of times I see users, they'll just look at the flare boom. They just want to get the dynamic response of the flare boom to design that, because that's going to be typically your most critical structure for your wind. But in this case, we're using the entire structure. Okay, so we've got the structure, and we're going to run a DynPack analysis, so we'll get our mode, shape, and mass files. Has it been run here? I might need to run it, because I don't see the mode files. Okay. So in this example too, this is I modified this sample 12 a little bit so that we've got, so I put some more input in than I'm going to recommend that you do too. And I'm probably going to go back and modify the sample files at some point when for one of these releases. So we are also doing a static analysis of the structure with the gravity loads. And this is to combine the wind loads with the static gravity loads, right? So the point of doing this static analysis is to generate the response, the common solution file from the gravity loads, so we can combine it with the dynamic loads. Okay, so that was fast. I'm not going to really talk about that too much. Just trust me, those have static gravity loads. Okay, so then let's take a closer look at the dynamic response. Okay, I'm going to turn all this stuff on. And so we have two files that I want to focus on. We have the model file, which has the structure. We have the mode, shape, and mass files, which we got from our dynamic analysis. And then we have this common solution file from the static analysis that we're going to combine with the dynamic response. So really I want to focus on two files. That's going to be the C-state input file for the wind and the dynamic response input file for the wind analysis as well. Oops, I wanted to click open with DataGen. There we go. Okay. Oh, I didn't modify this. I need to modify this. I'll modify it for you guys. Okay. So the first thing is you need to define a C-state wind load in your C-state input file or in your model file. And you need to have a wind load for every direction that you're doing the dynamic wind analysis. And if you're going to be doing multiple wind speeds, you might be doing different wind speeds, you need to do multiple load cases with those wind speeds as well. Okay, so we have, for this example, we have three directions. We have 0, 45, and 90, and we have the same wind velocity, 100 miles per hour. Yeah, don't let this trip you up. We do have different input wind speeds. And we have a reference height that's 33 feet. I'm not sure why they do this. Usually you're going to be doing it at 10 meters. If you leave this blank, it'll default to 10 meters, and that's typically what you're going to see. And that would be 32.8 feet. So I guess they're trying to make it a little bit rounder number. And then here we have a number of wind height variations. So um, this is going to be our wind height variation function that we're going to be using in the dynamic response analysis. I had a different um, wind height variation function in the PowerPoint presentations, the MPD wind height variation function, but this is just a different one. You can look into the C-state documentation for the various wind height variation functions and how to input or how these are modified. Okay, so we've defined all of that information, and um, in this C-state analysis option, they've set the C-state analysis option to win for dynamic spectral wind analysis. This is not necessary. It should, if you do a dynamic extreme wind analysis as your analysis type, it should automatically set the C-state option to win. But if you want to be careful, or double check to make sure that you're inputting everything as expected, you know, technically you ought to put this as win. Shouldn't be necessary though. Okay, so we've defined three directions. Now, this is a kind of our old dynamic response input, recommended input. We've since added some new input options for wind spectra that requires additional lines. And so I'm going to add those lines in so we can take a look at that and make sure that I want to make sure that everybody's aware that you probably should be doing that for your files as well. Okay, so we have a dynamic response analysis we're doing a wind analysis. Great. We are required to have some damping, so we've done a structural damping of 2%. And here we have the static combination. This is just saying that we're going to do a combination of the wind response with these dead miscellaneous area and machine loads. And we've applied load factors, and there's also the load case factor that we're applying here. So this is just how we're going to be combining the dead load response with the extreme wind response. Okay, and then here on the load line, we've got the spectral wind line where we're saying we're going to do an extreme wind analysis. We're not going to be printing very much, and these are just the plotting of the generalized force and response spectra. We have the spatial correlation function. This is an option, so you can turn this off. And we also have the gust spectrum option here as well. So we can define a specific spectrum for each direction. Okay. Now, there are wind averaging time, reference length, and roughness coefficient. I didn't really talk about these too much. These are these are really to modify the wind. The wind. You can modify the wind speed variation with the wind averaging time, reference length, and roughness coefficient. If you go read like API or DMD RPC 205, there's more information about this, but I'm not going to really get into this in this presentation. What I do want to focus on is adding this wind SPC line. This is something that has been added where we can add in the gust spectrum type here. You can see we've got the ability to select from Harris, von Karman, or Froya. And those, you can see that there's additional input that's required for the von Karman spectrum. I'm going to leave this at Harris for now. And one thing I am going to do, now this is more of a belt and suspenders approach here, because in this example, we really only have one wind velocity. But I'm going to go ahead and make sure that I'm selecting, or I'm inputting the wind velocity just as a double check, make sure. Now I'm going to repeat this 3 times because as we saw here, I'm going to specify the wind spectrum for each direction. And so I'm going to put in 45 degrees and 90 degrees. Now, on the latest version of SACS, this should produce the same output as if you didn't have this here, because basically what I'm doing here is I'm using default values. I'm using Harris spectrum to define all of these 3 directions. But there was a known defect, I think it was a few iterations ago, maybe SACS 14 or 13, where this was introduced, these WinSPC lines, and if you were using a Harris spectrum and you did not have these in your input file, it would produce different results, incorrect results. So that's why I recommend just go ahead and putting these in here. And this is a little bit clearer for your QA on your input as well, to make sure that you know where these load cases are coming from, the directions, and the velocities. Okay, so I don't know what I modified here. So that's really the input that we need, and let's run this analysis. Oh, let me check. Did it prompt me to? Did I save it? I did indeed save it. Okay. So let's run this dynamic response wind analysis. And we'll take a look at some of the output that we get from this analysis, and especially the neutral chart files and the listing files. Okay, so we've ran that analysis, and first I'm going to just jump into the neutral chart file. This is going to show us, as we requested, our generalized force spectra. And you can see here we've got generalized force spectra for each mode and each direction. And we also have a response spectrum for each mode and each direction. So you can kind of click through and view these, and you can see that we get the you can see the harmonic excitation from the mechanical transfer function and the contribution from the generalized force spectrum. So I'm not going to click through all of these, but these are here for validation purposes. And then we can see the wind spectrum at the end of all of the generalized force and response spectra. We can see the output of the wind spectrum. So this is repeated 3 times. We don't need to look at all of them, but this is available to you if you want to look at where the contributions of the response spectrum are coming from. Okay, and then let's take a look at the dynamic response listing file. Okay, so we can see the C-state input or C-state output, excuse me, of the some of the forces. So we can see what static wind load we're getting here. And we've got 45 degrees and 90 degrees. And if we go through here, I'm going to skip through this. This is pre-and-solve, so this is really just calculating the response of the, of the static wind load. Here we get into dynamic response. So here we have the definition of the 15 modes that we've gotten from our modal analysis. And then we can jump into the spectral extreme wind response. Okay, so our wind averaging time, our reference length, and our roughness coefficient. These are all the default values. And we can see here that we calculate the modal responses. So these are the responses of each mode to the generalized forces. And this is really our our RMS response. So we get the modal response for um, each one of the directions. And here, this is what I wanted to point out. You can see here that this is now in combined. So after we've done the dynamic response analysis, we have these modal factors. These are, well, I have to go back to the first load case, but these are the modal responses that we get here. And we can look, those are all of the modal responses right there. And we're doing this WSP combination with this. So if we go back to the PowerPoint presentation, we talk about what is this actually, this combination is doing. This combination is doing this modal correlation and CQC combination of the responses, okay? So here we can see that these are the dynamic modal responses for each mode. We're going to do CQC on these, and then we have the static wind load, and with the static wind load, we're going to be doing this computation here. So we're going to do the modal combination of these, and then do the static combination with the static wind load. And we do that for all three directions. And then we're going to be getting out 3 load cases. These are the extreme wind load cases. Now, I had a user recently talk to me about this, and they were trying to calculate the dynamic amplification factor, which they were trying to compare this force versus the static wind force. And that's not really the correct approach to be taking here. And the reason for that is we're using complete quadratic combination of the response. And these forces and moments are calculated from the base reactions in the structure. And when you do complete quadratic combination, if we look at the equation here, the complete quadratic combination is only valid if you're looking at the modal correlation of the first mode response times the second mode response. And when we do complete quadratic combination of the individual base reactions, I'm talking about the fixed joint reactions, those are combined individually. So you can't really do a base shear summation of the individual joint reactions because it produces different results than if you would do a complete quadratic combination of the base shear itself. I did a recent communities post on our wiki for dynamic response, specifically talking about this for seismic analyses, and that was if you go to the offshore communities page and go look in that dynamic response wiki, you can learn more about what I'm talking about here. But just be careful. It's much more, I would say it's much more appropriate to look at like a static internal load on an element and compare, especially for like a critical element, and compare the internal forces of the static wind load to the dynamic extreme wind load. That'll give you a better sense of the dynamic amplification factor. The dynamic amplification factor is going to vary because we do iterate over the elements when we're doing this, and you can get different dynamic amplifications for different elements. So that is something to keep in mind. And then at the end, we do a static combination of the wind load and the extreme wind load here and the loads from the static gravity loads. And that outputs another force summation. And once you have this common solution file, this is your final output, then you can do excuse me, I don't know why I'm tripping over my words today. You can do the code checks on the elements in this common solution file. So in this example, um, there is a post check which does post on that common solution file. I'm not going to go too deep into it because we're already kind of running long on time, but you can see just the input. We're just doing a code check with allowable modifiers because this is an extreme wind. Okay. So I think that closes it for me today. I'm going to go back and see if there are any questions. Let's see. So I'm going to open it to questions now, if anybody has any. Okay, looks like there are no questions, so I think that'll end it for today. Uh, Thank you all very much for attending. In, I think, 2 months' time, I have to go back and look at the schedule. We're going to have a Moses coffee corner, and then we'll be doing another uh, SACS coffee corner. Next time, talking about spectral wind fatigue. So there's some additional things that we need to consider when we look at fatigue, and we'll go into those when we get together next time. So thank you all very much for attending, and I'll see you next time. Goodbye.